Hello everyone, this is Jack Asamon. Today I'll be talking about work sampling. In this lecture, we will talk about another way to estimate work time, which is called work sampling. We'll discuss the methodology to conduct work sampling along with some examples. In some working environment, operators perform jobs that are non-repetitive. Work content is specific for each job, and there could be too many types of jobs to perform. Let me give some examples. Car maintenance technicians fix each car differently based on their diagnosis of the problem. Labelers may load or unload shipping containers with vastly different times depending on the things they load or unload. Forklift drivers may take different amount of time to take products from the shelf to the shipping bay depending on how far the product is located away from the shipping bay. So instead of trying to measure standard times, we may want to just find out what percentage of time is used for certain work. This is done by the process called work sampling. Work sampling is a process of making random and sufficient observations of operators' activities in order to determine relative amount of time that operators spend on various activities associated with the jobs. By random, we mean operators do not know when we come to observe. By sufficient, we mean we need to make enough number of observations so that conclusion is accurate within 8% of work time with 95 or 99% confidence. By relative, we mean percentage of time performing specific task. Before we discuss pros and cons of work sampling, let us see how we conduct work sampling along with some examples first. Step 1. We need to understand or establish the purpose of work sampling study. What do we want to know? What portion of time operators perform certain activities? Why do we want to know? Usually to estimate how busy our operators are. If they are getting too busy, we may need to increase manpower. Step 2. We identify people whom we want to observe, which is obvious from step 1. Generally, we inform the people we observe that we are conducting a study. They should do things that they do normally. Step 3. We need to list all activities that the subjects perform. This can be done by interviewing them and by informal observations. We may be interested in classifying various types of idle times. There could be many reasons why our workers are idle. If we understand the reasons, we may be able to improve or prevent the problem. Step 4. We determine when to make observations of the subject. The times must be random, not observing at the same time every day. Observation times must be spread across operators' work schedule. To do this, we need to randomly generate numbers between work schedule time. The table here is random numbers between 7 a.m. to 8 p.m. work schedule with 96 observations in a day. We can adjust the table to address some break periods in work schedules if you want to. Numbers in the table must be calibrated to meaningful time point. For example, the first number 1395 would mean 1300 hours plus 95% of 60 minutes. This would mean 1357 hours. Before we head out to make observations, we need to determine how many observations should be made in order to conclude our findings with confidence. We need to specify 3 parameters, all in percentage. First, percentage of time the subject performs the task. Second, accuracy of the conclusion. Third, confidence level. As always, we usually use 95 or 99% confidence. We can read Z value from the table. The required number of observations is calculated by this equation. Let's look at an example. We want to conclude that a job takes a minimum of 15% of operators' time, accurate within 10% with 95% confidence level. How many observations do we need to make? 95% confidence means Z equals 1.96. 15% of operators' time on a specific task means P equal to 0.15. 10% accuracy means A equal to 0.1. Putting into our formula, n comes out to be 2176.9, rounded up to 2177. Now we can go out to make the number of observations required. Definitely we won't make 2177 times in a day. We try to every workday until we meet our goal. Each observation we only take note what our subject is doing. One observation is one tick for an activity of an operator. Note that we measure frequency, not time duration. With the real data, we can calculate new work percentage P. If we keep percent accuracy and percent confidence the same, we can calculate required number of observations to make n new from the same equation. If the new n is greater than the old n, it means we do not have enough data to conclude for p new. We need to collect n new minus n more observations. If the new n is less than or equal to the old n, it means we do have enough data to conclude that operators perform activity p new percent of the time within a% accuracy with x% confidence level. Another example, a store would like to study how busy a cashier at checkout counter is. They would like to estimate with 99% confidence level that the working proportion concluded in the study is within 5% of the actual working time. We estimate that checkout cashier is working 75% of the time. Based on initial 21 observations, we can calculate the required number of observations to be 884. We decide that we can make 25 observations per day, so we generate 25 random numbers between 1000 hours to 1800 hours, then calibrated them as shown in the table on the left. Then we sort the time from lowest to highest and went to observe our cashier 25 times per day. Here we only mark working or idle. In most practical cases, we have many more classifications than this, and we do not observe our subject at the same time every day, so we need a new observation schedule every day. Here is an example of 721 observations. We can see that the percent of work time changed every day until we reach 884 observations. Another example, a company would like to see how productive are their maintenance workers. Based on preliminary observations and interview, there are 8 categories of activities our maintenance technicians perform, including being idle. We would like to observe for the next 30 days with 90% confident that the results accurate are to be within 10% of true time spent on their activities. And we can estimate the portion of time spent on the shortest of major tasks P is about 8%. This requires 3,112 samples. After we make observations, here is the finding. Here the smallest p is 2%. If we recalculate n new, we would get something higher than 3,112 samples. So we need to collect more observations here. As you can see, work sampling is quite easy to perform. No need to measure time in stopwatch. No need to work closely with operators as we only observe what they are doing. The disadvantages of work sampling are we cannot get time estimate for each activity. We get percent of work time to perform an activity. We can observe only a limited number of operators at the same time. If operators are not in the same place, we may be unable to observe operators at the exact same time. Well, this is it for this lecture. If you have any questions, please feel free to leave it in our Google Classroom, and I'll be happy to answer the question. Thank you and have a good day. Bye.